In this video we will talk about functions and specifically also define what a function is. Now in order to get there we will have two prior definitions to kind of help us find the words to then clearly define what actually a function is. So the first definition I wrote up as a not so academic definition, hopefully helping to understand what that rather abstract concept is, and that's the idea of a set. So a set I'm defining here as a bunch of somethings that share a belonging. Sometimes the belonging is simply that you say these things belong into a set. So it can be a pen and a pencil are a set just simply because you say so. Now we can have a set of numbers, for instance, I'm listing here. We can have a set of countries, a set of states, a set of people, and anything you can ever think of you can make a set of. That a bunch of somethings, so our set, that it is a set can be shown in different ways. So the first thing we can do is we can use words to describe it and just say the set of all students in our class, for instance. Another one could be that we are just using curly braces, and you kind of know that already from our solution sets. You've used that already. You just write the solution in curly braces, and if you have more than one you use a comma in between. Or in the same way you can just list numbers in them, or in this case I've selected a few countries that start with the letter N. We can use numbers on a number line. So on our number line that we have here, I can, for instance, select 1, and I can select -3, and I can say that is my set of numbers. And I can also just write something, a few somethings again, some elements we often say of my set, and draw a box around it, and then that resembles the set. So those are a few different ways how we can show that we have a set. But mainly when we call it a set of whatever, then it is a set of whatever we are having a set of. Now, what we're doing next is now looking at having different sets and putting them into relation. So our next definition therefore is called a relation. So that means we can relate one set to another, and that correspondence between the two is a relation. So that's what we have here. Now again we can show the relations in different ways. We can again use words to describe the relation. So we can, for instance, say each student in our class will receive a grade, and that is a relation, right? We're setting the set of students in relationship to the set of grades. Another way we can go about it is we can use our boxes of different elements that we have of two different sets, and just simply draw lines between them and draw arrows and say, here I have different states, and on the left and on the right I have 3 different numbers. Now it turns out those numbers actually are the number of representatives in the House for each state, because Alaska and Colorado both have 7 representatives. California has 53 representatives, and Florida therefore has 25 representatives. Now we can also write ordered pairs. So those are the last examples here. So we can just write these same states as an ordered pair with the number that shows what the number of representatives in the House that particular state has. And then I have the set of ordered pairs that lets us have that shows different states with different number of representatives. Actually, I added one more, North Dakota in this case. Now, we can also just randomly put different numbers together as ordered pairs and say it's a set. Then we have a set of ordered pairs of numbers. And then the last one we have is we can take those ordered pairs and declare them points, and then we can plot those points in a coordinate system and make a graph. And then so that is another way of showing a set of ordered pairs of numbers that by just graphing them in a coordinate system. So that is basically what a relation is and the different ways in which we can show the relation. Now, out of all these possible relations, we will take some specific ones out, and those ones we call a function. Now, what specifically do those relations have in common that make a function? So a function is a relation that associates with each element of a set X exactly one element of Y, another set. In other words, for a function, every input has only one output. So for instance, if I go back up to our relation of the states and the number of representatives they have in the house, each state has exactly one number, right? So Alaska has 7 representatives. It does not have 7 representatives and 15 representatives. It has 7. And so it has one number. Now it is possible, like Colorado has the same number, that is okay. But it would not be okay for Alaska to have 2 numbers. Here, actually, that particular relation would actually also be a function. So that is one example, and we'll talk about another one. So the input in this particular example would be the states, and that is what we call the domain. And then the output would be the number of representatives in the house, and that is what we call the range. So that is the set of all outputs. Now we can write functions just like relations. We saw different examples just a minute ago, and so that all holds true also for functions. However, in addition to that, for ordered pairs, we can also write that our output equals f of x, and say y is a function of x. That is what that means. So that usually means that we have some algebraic expression. For instance, we could say y equals 2 times x. So for instance, as an example over here, we could say that y equals f of x and say that that is 2 times x. That means every output is double the input. So if I have an input of 3, the output would be 6, for instance. And that's just one very small example. You've already seen many functions, and we will get to know more functions as we continue. We call then x the independent variable, or also the input that we've already named just now. And then we call y is the dependent variable, or known as the output, because we take x and we do something with it, like multiply it by 2, and then get the output. So it depends on the x. So the y depends on the x, but then the x we can freely choose, and we will show more of that in subsequent videos. Now f is simply the function name, and there can be different names. There can also be g and h and l, or whatever a name you would like to give your function. So I'd like to show 2 more very brief examples, and then more will follow in subsequent videos. The first one is we want to talk about whether or not a relation is a function. So the first example is the set of ordered pairs of the form student and grade. Now let's think about, if I give every student 1 grade, that would make it a function, because few students would like it to have at the end an A and a B. They would like their A, right? So every student has 1 grade at the end, and therefore this is indeed a function. Now for the second example, we are looking at the set of ordered pairs of the form grade students. Every grade, so let's say A, has many students assigned to it, hopefully in our class. So that means many students can have an A, but because the grade is the input, right? So it's our independent variable. We therefore can say that this is not a function, because every grade can have more than 1 student assigned to it. Now we can also think for a second about what is then the domain and the range in each example? So for the first example, our domain is actually all the students, and the range then is the set of our possible grades, which we could also write out directly as. Now in the next example, it is actually the other way around, right? Because now the input are the grades, while the range is now the set of all students. So that's in these two examples turned around. So that is the basic takeaway of this particular video, is to understand that a function is defined as having for every input only exactly one output, and that the inputs are called the domain and the outputs are called the range.